Hey guys and gals, Blender Tech here, and welcome to another video from the team here at BlenderTech.com. If you enjoyed or learned something from the video, consider liking it and subscribe for more Blender, Unity 3D coding, and all sorts of other CG related videos. Lastly, don't forget our motto, create your way. So when we left off in the look and move tutorial, we just quickly went over. It was a code giveaway kind of, where we could look around with the mouse. We can now look up with the mouse, we can look down with the mouse, and left and right. And you can see our character making the movements that it should. So let's make our character move now. Again, this is basically a code giveaway for someone that has little or no coding experience, that maybe wants to just get a script and then pick it apart themselves. But I'll try to explain things as best as I can. So we'll be working on the player movement script today. So I'm going to open that up. And remember that I am using Visual Studio instead of Mono. However, it works exactly the same. The only difference is going to be the look, and the only difference is I'm able to debug within Visual Studio. Whereas if you want to debug, you'll have to edit your script. You'll have to, do something, and then save it, and then go into Unity, and then you'll see if there's any errors down here or in your console. So anyways, let's get started. So let's start by setting up our multi-line code, telling ourselves what we want this script to do. So like I said, I do that just below the namespace, which is this line up here. So what I usually do is I do a multi-line comment, which is done by a / followed by an asterisk, and then I type in a little comment that tells myself exactly what I want the script to do. This way I have a goal, and at the end I can change it. I can say this is what the script does, and this is what this does, and whatever. And you'll see this in a lot of scripts where people usually leave like their contact information and version information up here. So you could even add your script version number. I'd say something like, in this script I want to take the keyboard input to move the character, and have the character also move wherever we are looking by referencing the mouse look script. Oops, and ending that off with a asterisk /. So yeah, just a little comment I leave myself that basically I can always go back and look at and say, this is what I want to do. So yeah, basically I want to just take keyboard input, so like WASD or the arrow keys, to move the character around, and we also want to have the character move where we're looking. What I mean by that is that if you didn't have it reference the way the character's looking, we would be able to move forward and back and left and right, yes, but we'd be able to look at the same time in any direction, and where we're looking wouldn't affect where we are walking. And that's desirable sometimes, say in a third-person shooter, or if you're in a car game, when you want to have, say, the car just moving forward and left and right, and you want to be able to look with the mouse. But in this case, wherever we're looking with the mouse is where we want our character to move. So let's continue working on the script. Let's set up our variables first, just as before. So remember, in C# you have to define what kind of variables you are, and in this case I'm going to make them again all public. Difference between public and private: public means you can see and adjust them in the editor window, in the hierarchy, or sorry, in the inspector window, just like this. I've made these all public right here so that we can adjust them when we're playing, or you can adjust them through here. And if they're private, you won't see them there. But you can also hide public variables. But anyways, I make them all public so that you can adjust them and see how they're working when you're first working with scripts. So anyways, we have to define what our variables are in C#. So all our variables are going to be floats again. So our first one is going to be a float variable, and it's going to be called walk accel. You could go acceleration, I guess. Walk acceleration. And then just give it a starting value somewhere around 5. And so that's basically just going to be a value that says how fast we walk, more or less. We're going to make another public float called run multi, so that's run multiplier, and I'm going to make that equal to 1.75. Sorry, floats have to be ended by an F. They don't have to be in latest versions of C#, but it's always best to. So in this case, I would even put a 5.0 to remind myself that it's a float, because a float is a number like 5.0001, whereas an integer would just be 5. So sorry, just to describe that a little bit, and so the run multi is just going to be used to multiply the walk acceleration by a certain amount. So when you press a key, you can walk that much faster. So when we press a key, we'll be able to run 1.75 times faster. And you don't have to put this part in, you can just have the walk part. But when I made this script originally, I edited it a bit so that you could have the run multiplier in there. Our next variable is going to be public, and the type is going to be game object. So I guess they're not all floats. That's just letting Unity reference a game object in itself, which can be the player, the cubes, the plane, the light. It can be any game object basically. And the game object variable is going to be called camera object. But we're not going to assign that to anything yet. This variable basically, it's like I said, a game object variable, so you can look that up in the scripting API if you've forgotten how to do that. You just go to Unity and press any of the little blue bookmark buttons, and then it'll open a browser window, and you can go to the scripting API and look up anything here, and it's got very, very, very good stock documentation. And so basically, yeah, that the camera object variable, it allows us to save a game object instead of saving a value or a string. And so this way we'll be able to access our mouse look script or any other camera scripts that we might have. This way we can get the Y rotation from the mouse look script so that we can walk in that direction. And that's really the key to this script. So the next one is, I believe that is it. No, that's it for this. It's fairly basic. Now there's two ways we can do this. The way I've done this, again, we're not going to use anything in the actual start function. You could get rid of it, but like I said, I like to always leave them there just in case. Everything's going to be in the update, but what we're going to put in the update function is just a simple if-else statement. And if you've never used an if-else statement before, it works like this: if something happens or is true, then do this, else else do this instead. So it's basically just if this is true, do this, otherwise always do this. So I've made this script a little bit more flexible and a little bit more interesting, and introducing you to a new concept of making your own functions. And this really isn't needed, but it just introduces you to how it works. So we're just going to go if input dot get button, and we used this one before, sort of, run. Now there is no button on your keyboard named run, obviously, but I'll show you why we're going to use run. Then run with capitals, or sorry, in capitals. Oops, not runtime. Run in capitals with the brackets after it, followed by a semicolon to end our expression. we're calling a function there, and that'll make more sense in a minute. And then our else is just going to be walk. Whoops, calling my variable instead of the function because I haven't made the function yet. Oh, come on, you son of a gun. There we go. So yeah, the name RunWalk does not exist in the current context yet, but it will. So if input.get button run, then we're going to run, otherwise always walk. And so what we've done here is we're just calling functions. And again, this is more complex than it needs to be, but it introduces you to the concept of making your own functions. These here are functions. So let's create a run and walk function. And they're going to be exactly the same, just slightly different. So let's do the walk one first. So we'll just copy the way they've done it in Unity. We'll just go void run. Sorry, walk, I guess we're going to do first. So you do it just like that. So just like they do it in Unity. You don't have to put the brackets right beside it, but that's the way I do it so that I remember how to... Then I remember it's my own function, and then you just fill it, you just add curly brackets, and basically whatever's in between here is what happens when you call walk. And you can also add arguments, but that's a more advanced topic, so we won't get into that today. It's just going to be simply creating your own functions. Like I said, you really don't need to do this, but hey, it's always good to introduce a concept kind of as a I don't know, it's like a mental note that you'll pick up on one day. So in our walk function, I'm going to leave myself again a little note. I'm going to say we're going to reference our mouse look script to get the current Y rotation. And what else? Yeah, basically we want our character to walk in whatever direction our keys are pressed and we are looking. So I'll end my multi-line comment. You could have just done this with a regular comment, which is the 2 forward slashes. So we're going to start this off with a... Oh, I didn't end that properly because it's not a multi-line comment, so we're just going to do a regular comment. So we're going to start this off with a transform dot rotation. And I think we used this last time in our script. So I'm not going to go over it again, but basically we're just transforming our whatever this script is attached to, whatever object you attach it to, transformation, obviously like a scale, a rotation, or a movement. So in this case we're doing a rotation, and that's going to be equal to quaternion. Now, oh, there it is, quaternion dot Euler. We went over what that is last time. Basically, a quaternion is just a way to do rotation in Unity, and Euler is just another way of doing rotation. I showed you how to just copy that and then paste it into the scripting API search, and then get some more details about it because I didn't want to spend 20 minutes describing exactly how it works. And so basically what we found out is it either takes a vector 3, which we haven't gotten into yet, or it takes an x, y, and z value, because obviously you would rotate by an x, y, and z value. So our x is going to be 0. We're not going to move in the x direction. Our y is, this is where we're going to use our other script. So it's going to be camera object. So that's our variable we made, remember? Our variable up here, we're now using it, we're now assigning something to it. Dot get component, so we're getting a component from something, and we're getting the component from mouse look. And when you put it in the arrow brackets like that, that means that we're referencing something from there. And so what are we going to reference? Well, we're going to reference current Y rotation. Now normally that would have turned red because now why is this one turning red on me? Anyways, normally this variable would turn red and give us an error if we just tried to use it in this script. But because we're now referencing this script, that means we're able to use that variable. And in our mouse look script, the current Y rotation, if we had made that private, then we wouldn't have been able to reference it like that. So that's again another difference between public and private variable. Oh, I realized my mistake. Now we just have to add two brackets into there, because the get component is a method. So yeah, and then our Z value is simply 0 because we don't want to move in the Z. So this is basically just saying that we're going to rotate only in the Y. And you remember if I showed you that graph where X was horizontal and Y was vertical, and the way rotations work is as if you were spinning around them as if they were poles. So that's why this is going to be a horizontal movement, even though we're going to get vertical movement in the end. So I've just gotten rid of the run one for now, so it's not spitting out an error, but we can see just like that we've got no errors. So let's create our run function and test this. So I'm actually going to turn that back to run. And we will make another space and then just go void run caps, and then open and close brackets, and we'll put our curly brackets, and we'll just leave it empty for now. So it's a function, but it doesn't do anything, but it fulfills everything that our script needs, so we have no errors. So let's test it. Let's see what happens. So we're going to take our player movement script, we're going to attach it to player, and you'll see now down here we've got our walk acceleration variable, we've got our run multiplier variable, and we've got camera object. Remember, it's asking for a game object, but right now none is attached to it. So what we want to do is we want to attach something to it. We want to attach our camera to it. So let's just click this little button here, or you can drag and drop, and let's choose our main camera, because that is our camera object obviously. But if we hit play, we still get the same thing. Nothing happens. No matter what buttons we press, we can only just look around. Now, one reason that's a problem is you can see down here, input button run is not set up. So to make your own inputs that are not standard, like space or the arrow keys or whatever, and if you want to find out what some are, you go edit, project settings, input, and then down here you've got size is just how many there's going to be, and you've got all sorts of ones. So you can see there's no run in here. We've got horizontal, vertical, we used mouse X and mouse Y in our last script, but we need a run, which would be similar to horizontal and vertical, but in this case I wanted run to be its own. So we're going to add another one. So we're going to just change this to 19, and we get a duplication of cancel. This one's going to be called run, and it wants a positive button. The positive button is going to be left shift. I think that's the name. No, left shift. I always run into these. I can't remember the key codes. Right, okay, I remember now. Unity's finicky. So the positive button is going to be left shift, because that would be the button that you usually push to run. But you could also do the negative button as right shift, so that they can press either one. And this is just a way to make your own inputs. And we could have also just done, whoops. We could have also just done if input dot get button key code dot left shift, but that's a little bit less flexible. So that's why we're going to use our simple run string, and then we're able to edit it in the actual Unity input manager. So let's see what happens now. So if we hit play, still nothing happens. Why is that? Well, that's because we've called run, and if we're not calling run, we're calling walk. And there's nothing for run, so it's skipping over that, so it's calling walk. But right now, it's doing nothing. It's doing nothing in the Z, it's doing nothing in the X, and in the Y, it's just getting the current Y rotation from the mouse look script. So we need to actually do something with that data. So what we're gonna do is, we're gonna do rigid body, and I'm sure you know what a rigid body is by now. That's basically just a physics thing that you add to make your object interact with other objects. We added it to our player in Unity. Our player doesn't have a rigid body controller. I think we need to add one. So we would go component physics rigid body. And then that way, if we pull him all the way up, he's gonna drop onto the ground. And you see, we can look around. Yeah, that's what a rigid body does. It allows an object to interact with the rest of the game world. But anyways, yeah. So that's what the rigid body does, and we're gonna add let's see if I can spell this, relative force. So we're just gonna add a force. There's add force and add relative force. Again, you can search up the differences. Basically, add force just goes continuously. And the force we're gonna add, it tells us there's one of four ways we can do. We can do a vector 3, which again, we're not gonna get into. We can do a vector 3 force with a force mode. We can do a float X, float Y, float Z, or we can do a float X, float Y, float Z with a force mode. So in this case, we're just going to do another X, Y, Z to keep things simple. And so in this case, our X is going to be walk acceleration. Times input dot get axis horizontal. So this is the one that we used in our mouse look script, I think. We use, yeah, dot get axis mouse X and dot mouse Y. In this case, we're using horizontal. And if we go back into Unity, into our input manager, you'll see horizontal is the, why is it not, oh sorry, I got wrong one. The horizontal is left, right, or A and D, and vertical is up, down, and S and W. So that's what horizontal means there. And in the Y, we obviously want no movement. And in the Z, we're gonna just simply do the opposite. Walk acceleration times input dot get axis. And again, it's asking for a string axis name, and then in this case, we're going to use the string name vertical. Whoops. So let's end with a semicolon, make sure we have no errors. Nope. Let's save it, and let's see if that does anything. So we hit play now. We fall to the floor. And we press forward. Nope. Essentially right now we can only move wherever we're looking. So you may be saying to yourself, well, that didn't do anything. We're still getting this weird movement where we can't really move around, but when we look, he moves in that direction, and we can give it a little bit of force, but nothing's really happening. Well, this is because what we've done here is when I first showed you the mouse look script, I attached it to our player capsule. You can see it right here. We don't want that anymore now that we have our player movement script on our capsule. So let's actually delete the mouse look script. So we'll right click and remove component, and let's actually add our mouse look script to our camera. That way basically the camera is looking but the player is moving. Otherwise, we're getting, yeah, that really weird function where the player was able to rotate his entire body because of the way the scripts were set up. So now that we've done that, now that we've put the mouse look script on our main camera, and we've still got our player movement script on our player capsule, let's see what happens now. So we hit play, he drops to the ground, look around. Oh, he's not sliding around anymore. Let's try walking around. So if I hit W, oh, he moves forward. Well, he's really doing some weird head bobbing movements, but he's moving quite fast. I can't really control that. Well, that's because we adjusted that multiplier thinking that something was wrong. So let's set it back to 5, which was our original guess, and hit play. Now we can move around. Now clearly there's something wrong because it's rotating really weirdly like that, or it's jumping up and down. I'm not quite sure what's going on there. I'm gonna have to figure that out, but you can see that we can now completely control it with our keyboard, and wherever we're looking is where we're going to move forward. So I'm just holding down W right now, and I can essentially walk around this box minus the weird screen tearing that's going on. But you can see in the scene view it works just fine. Well, I'm not sure why it was so jerky, but by going to the constraints tab in the rigid body component of our player, I was able, by just checking off freeze rotation on all axes, I was able to solve that. I don't know why that was happening. That never happened to me before. But yeah, you can see that now I can walk forward, I can walk backwards, I can go left, I can strafe, I can go right, and say I'm looking right at this box. If I press forwards, I go right towards it, and I hit it. Now that's a little bit slow, so now maybe we would wanna touch up our acceleration speed, maybe to something like 10, and then hit play and give it a test. So yeah, that's a lot better. But you can see that when we move and let go of the key, we keep moving. Now that works, but it's not perfect. It feels like we're kind of on like half ice, you know. We really slide quite far, so we need to add a bit more to this code to be able to get it to work more like you would have in a regular FPS movement script, or any player movement script. But this is just the beginning. But anyways, enough of that. Now that we've got that weird jerky problem that I've never come into before solved, that might become an issue, so I'm gonna have to definitely look into that. I don't know, that's never happened to me before in any Unity game. But let's quickly just finish off our run part of it, because it's very simple. We're just gonna copy and paste this into our run function, and so it's the same thing. We got our transform.rotation, so we're getting the current Y rotation, we're referencing it from the mouse look script, and then we're adding a relative force to the rigid body component added to this object, whatever object the script is attached to. And so we're adding a force relative to the rotation, and we're going to add all this. But in this case, we're going to do walk acceleration times run multi times the input.get axis. And so if we save that and hit play, we can now go forward and backwards, but if we hit shift, we have turbo speed. So we're running. Whoops, I fell off the edge. And that's another problem that we'll have to solve in the future with some scripts. And if I let's maybe turn the acceleration down to 5 again to see this, and maybe the run multi up to 3, so that we can get a more visual reference to this, since there's no way to know if we're actually running or not other than seeing it. So if I press forward, we move very slowly. But if I hold down shift and move forward, I move very fast. And I also strafe very fast. And if you don't want to be able to strafe very fast, if you want to be able to strafe normally but run fast whenever you're running, just get rid of the run multi-part in the vertical, or sorry, in the horizontal. So when you're pressing A and D, that way it won't multiply it by your run multiplier number. So that is basically it. So again, we didn't need to really create this little if-else statement, but it introduces the concept of creating your own functions. Because once you start getting more and more complicated scripts, for example, we might create a jump function, or you might create, I don't know, something else. But that way you don't have 800 lines of code in your update function going on and on all the time, every single frame. It allows you to call functions when you need them, and you can get more advanced with functions, obviously. Otherwise, why would they be there? So that is the basics of the player movement script. I'm just going to save it one final time, and we also have our mouse. Whoops, I moved our mouse look script from before. This is just the code here. If you guys missed it from before, this should be all you need to see. Yep. But you can just watch the video. And so yeah, I don't know why that little juddering problem was happening, but freezing rotation fixed it in my case on the rigid body. But you shouldn't run into that, because I never did before. Maybe it was just some weird way I had it set up. But yeah, now we can walk around, or we can run. But it's very basic, however it works. However, in next lessons, we will improve upon it, and we will get a full-fledged script that works more like the AAA quality games. But for the moment, you can now run and walk and look around wherever you want. So hopefully that helps you out in starting your own game. Now you can explore the levels that you build, and you have some script basically given to you to do so. So if that helped you in any way, great. If not, there's lots of tutorials out there on better ways to do this and different ways to do this. Like I said, in our mouse look script tutorial, there's usually at least a couple dozen ways to do to do something when you're scripting, if not hundreds. But anyways, thanks for watching from the team here at BlenderTech.com. If you enjoyed this video and learned something, consider liking, and don't forget to subscribe for more videos. We're on Twitter at twitter.com/blender_tech and Facebook at facebook.com/blendertechpage, all one word. If you dislike this video for some reason, don't just hit the thumbs down button and leave. Instead, please leave us a comment, or if it's private, email us at info@blendertech.com about what you did not like, so we can continually improve our videos based on community input. That's what our original goal was when we created Blender Tech. We also take requests for tutorials or personal help lessons, so if you're struggling with something or you want to see something, just let us know and we'll make a video up. Anyways, see you next time. Remember, create your way.